Thanks for the introduction. I'm just going to kind of talk about the preliminary work that I've been doing for the wind forecast, so wind gusts and wind speeds from the HRRR, and kind of continuing on from what we've done. So just a really brief outline. I'm going to start with a real quick introduction / motivation that we kind of already went through with Rob's presentation. Then I'm going to get into my wind speed validation that I've done so far, look at the wind gust validation that the HRRR has their post-processing and they have a wind gust variable, and then just some conclusions that I've gathered from my work thus far. So just really briefly with the motivation, we can see that Wyoming's very windy and the strong winds correspond well with the terrain. And as Rob mentioned, there are a high risk of truck blowovers and blowing snow, so understanding how well the wind forecast for the HRRR does, we can hopefully find ways to improve our forecast to reduce those blowover risks, or at least warn the trucks and the public that there is a risk of high winds and go on your own risk. And also, there is a video online you could look up that did not work to be put into my presentation, but on February 7, 2017, there was a truck driving down I-80 in Wyoming, and a strong wind gust came and it fell onto a cop car and crushed it. So if you search, I think if you just YouTube like February 7, 2017 truck in Elk Mountain, you can see the video and it's kind of alarming and is really good motivation for wanting to improve wind gust forecasts. So really briefly, all of the things I'm comparing to, so we are using currently 3 seasons, so 2016, 2017, 2017, 2018, and 2018, 2019 December to February seasons. I have compared to the Meso West observations for comparison, and the figure on the right is the current box I am using to compare, so all the points are Meso West observations that I have in that box, and I bilinearly interpolated the HRRR to every single individual point, so it's comparing apples to apples to the best of our ability. And furthermore, I'm only currently utilizing forecast hour 6 and initialization times 0, 6, 12, and 18Z. So that gets a little confusing, so essentially if I am comparing the 0Z initialized HRRR, I'm comparing it to the 6Z observations. Okay. So beginning with the wind speed validation, if we kind of look at all these joint PDFs, so on the top 2 are the 2016 and 2017, 2016, 2017, 2017, 2018 season, and the bottom left is the 2018, 2019 season. And just really quickly, if the joint PDF, I'll just explain it in case someone forgot what it is or is confused because it's been a while. If we add up all of the points, it equals 100%, and every individual point is a frequency of the observations on the x-axis to the modeled wind speeds on the y. And just looking at it, we can see that the slow wind speeds are slightly overestimated by the HRRR, while the extreme winds are significantly underestimated by the HRRR. And that can also be seen in the slopes of the best fit line. They're all less than 1. Also looking at the R-squareds for the 2016, 2017, and 2017, 2018 season, they're not great. They're 0.3 to 0.4. But the 2018, 2019 season is significantly worse. And we are looking into if that is an issue with changing the version of the HRRR for that season, or if it's some sort of seasonal issue that season just does not perform as well. And then the bottom right is combining all 3 seasons into one panel, and it's pretty much the same result, where the slow winds are slightly overestimated, but the extreme winds are significantly underestimated, and the R-squared, when compared to all of them, is 0.35. So another way to look at this is these figures, which I will also explain because they get really confusing. So the x-axis is the observed wind speeds, and I binned the observed wind speeds by every meter per second, so 0 to 1, 1 to 2, 2 to 3, etc. And then on the y-axis, I took the difference between the model points and the observation. So if the observation was 0.5 and the model was, let's say, 10, I subtracted the 2. So we can see that all 3 seasons, this trend shows up where the slower wind speeds are kind of in the positive, and then around 4 to 5 meters per second, it starts shifting towards the negative values, which means the observations are larger, and by the extreme, so kind of around 20 to 30 meters per second, they're essentially not represented at all. And once you get down close to 50, especially in the 2018-2019 season, you can see that it's essentially, the model's not predicting anything. It's almost minus 50, which is essentially, yeah, which is not good, and the results are generally consistent across all 3 of the years. If we combine all the seasons, we can see that, once again, the trend is the same, where it just is underrepresented by the slow winds, or sorry, slightly overrepresented the slow winds, but significantly underrepresenting the fast winds. Okay, so here's another figure that I will briefly explain that is also slightly confusing, and it took me a while to wrap my head around. But so on the x-axis, I took the difference between the model and the observations for different bins. So this figure is bin from 0 to 10 meters per second. And on the y-axis, it's actually, that's a typo, it's not percent correct, it is the percent in a bin. So each point is a one bin, so if the point, I don't know how to do the pointer, so this point is, if the model minus observations is between 0 to 1, that's the point. So so the y-axis is technically the percent that falls in that 0 to 1, 1 to 2, minus, or 0 to minus 1, minus 1 to minus 2. So we can see for the 0 to 10 meter per second bin that it's kind of shifted slightly to the positive values, or on the positive side. But as we step through, so to 10 to 15 meters per second, it begins to shift towards the negative, where the observations are beginning to be larger than the model. If we shift to 15 to 20 meters per second, that shift to the right to the negative values continues. And finally, if we look at 20 meters per second or larger, essentially all the points are on that negative side, which essentially is saying that the model is not representing anything, for the most part, of 20 meters per second or larger wind speeds. And the results are also, once again, generally consistent between all 3 of the years. So just a brief summary of the wind speed validation results that I keep reiterating. So the HRRR overestimates slow wind speeds, but it is significantly underestimating the very strong wind speeds. And the results are consistent across the last 3 seasons for the most part. So stepping into the wind gust validation, so really briefly, this was taken from our C-STAR proposal. In order for the post-processing for the HRRR to calculate the wind gust, they begin by calculating the depth of the PBL, and then they use this equation to kind of weight the excess wind speeds from there, and from that, they are able to generate the wind gust value that is outputted from the HRRR. So once again, looking at these joint PDFs, we can see that the results are consistent with the wind speed, where the slower wind speeds are slightly overestimated by the HRRR, but the stronger wind speeds are, once again, underestimated by the HRRR. It should be noted that the wind gust variable does do better than the wind speed, so the R-squareds have improved, and overall, it is doing slightly better than the wind speed variable, which is good, but it's not doing great. And once again, the 2018-2019 season is not doing very well, and we're trying to figure out if that's a version issue or just the season. So looking at these again, we can see that the slow wind speeds are slightly overestimated. However, the location at which the shift from positive to negative on the y-axis has moved to a larger value. So now it's between 7 to 10 meters per second instead of 4 to 5 meters per second. So it is doing slightly better, but still not great. And once we compare all of the seasons, it averages out to like 8 meters per second is where that crossover occurs, but still consistent with the wind speed where it's not doing very well, but still slightly better. So looking at this weird figure again, we can see that for the 0 to 10 meter per second bin, it is kind of leaning towards the positive, where the model is slightly overestimating the wind gusts. But as we step forward, so 10 to 15, it starts to shift. 15 to 20, it still shifts, and it kind of is leaning towards the negatives at this point. And then by 20 plus meters per second, so anything larger than 20 meters per second, it's almost all in the negative. However, if you remember back to the wind speed one, there are significantly more points that are in the positive side of the x-axis. So the model is doing slightly better at these faster wind gusts. So the summary of the wind gusts are essentially the same as the wind speeds. So they are overestimating slow wind gusts, significantly underestimating strong wind gusts, and the results are consistent across the last 3 years. And then the conclusion slide is essentially the same, but I should note that the wind gusts do slightly better than the wind speeds at the extreme winds. And yeah. So with that, I will take any questions or comments or suggestions on how to represent the data if anyone has any. Yeah.
As always, I have a question. Sorry. This is cool. I like this kind of stuff. So since you see that the gusts did a little bit better, how do you feel the HER is representing the mixed PBL then?
So I haven't looked into that yet. I think that's kind of a next step, is to look at mixed BBL and kind of look at some of the cases. So all I've really looked at are overall everything that happened in that entire season and seeing if there's a trend in the entire season. But I do think that it's important to see how it's representing the PBL, if I could look at an individual case for some of those extremes. So I guess if I go back, so if I could identify the specific cases that have the extremes and kind of analyze what the model is doing really wrong with that, or if there's something, if there's a specific variable that's messing it up that messes up everything, right, maybe, or whatnot.
Critical for the momentum transfer there.
Yeah.
Also, is the fire, have you spoken much to the fire community about, I mean, I think they would do some of this stuff too.
We have not. We work with Trevor Alcott at Esrol, so he might be talking with them. I'm not really sure.
That's something we need to bring up.
Yeah.
That's a good point.
But I think one of my friends is at NCAR, and I believe there's a new PBL scheme that's supposed to be released eventually that I think they gear towards fire, so it might help improve winds as well. But I'm not positive about that one.
Yeah, I think, excuse me, HER V4 is 2020, spring 2020?
I believe so, yeah.
So the first 2 seasons are the...
I think they're V2, and then 2018, 2019 is V3, I believe.
Other comments, questions? Okay, thank you so much. We are going to go straight to our last presentation of the day. Once it is done, do not just rush out of the room. We do have some closing words, and we are going to take a group picture afterwards, and we'll give more details about that after his presentation. Let me get that pulled up. There we go. There it is. Perfect. Explode everything. So in his second presentation of the day, we have Brian Bargenbroek. I can spell, I can say things, I swear. Words are hard. Again, from the Omaha office, except this time we're going to continue